Hi there, welcome to this Java interview guide from In 28 Minutes. In this series of videos, we are covering a lot of interview questions on different Java topics. As you already know, In 28 Minutes is famous for all its interview question videos. We have interview question videos on Lambda expressions, multi-threading, collections, exception handling, and also we have a lot of different videos on JUnits, design patterns, Eclipse, Mockito, Spring MVC and stuff. In this series of videos, we are covering interview questions on OOPS, Advanced Java, Servlets, JSPs, design patterns, JDBC, J2EE, Maven, and Eclipse. All the information about different questions that we would discuss is on the GitHub repository. github.com in 28 minutes. Hi there, welcome to this video on Maven interview questions. There are quite a few resources on Maven which are available. So this is a GitHub repository, Maven in 28 minutes, which we are going to use extensively during this particular video. Also, you have a video to watch on Maven. It's about 90 minutes. And also, we have a full course on Maven, which is one of the most popular Maven courses on Udemy, which you can look at it down here. So there's a discount coupon on there as well. So you can follow that. So if you like the content of this video, then probably you can do that as an after step. So let's quickly get into Maven and see what are the things that it brings in. What is Maven? The fact is that defining what a Maven does is very, very difficult. There are a lot of things that the everyday developer does, right? So you manage dependencies. So I use Spring MVC, Struts, JPA, Hibernate, and a lot of other frameworks. I need to manage them. Do you want, like with Ant, the way we used to manage them is to download the jar, put it in a folder, and whenever there is a new version, download the new version and put it in the folder, make the folder available to everybody. And if there's a problem with the folder, then everybody is in a problem. So that's the way we used to manage our dependencies. With Maven, you don't need to do that. You just need to say, I want version 5.0 of Spring. Okay, it's not yet there, but yeah, I can say I want version 4.2 of Spring. And I can easily use that. So Maven helps us to manage dependencies. The second thing which Maven helps us to do is build a jar, a var, a EAR. With Maven, I don't really need to do a lot of things. I can easily build a var, EAR, or a jar. Earlier, we used to write Ant scripts, running into hundreds and hundreds of lines of code to build a simple jar, or a var, or an EAR. Maven helps us to run applications in Tomcat. I just need to say mvn tomcat 7 colon run. I'll be able to run an application in Tomcat or JT, mvn jt colon run. I can deploy an application to an environment. So we used to have a script where I used to say mvn deploy colon t, and it would deploy to the t environment or the test environment. And you can add new dependencies to projects, and you'd be able to run unit tests as well. You just need to say mvn test and you can run the unit tests. And Maven makes it very easy to integrate into continuous integration server as well. So you, in the continuous integration, all that you need to give is this is the POM file. All that you need to do is do mvn install, and mvn install does not throw an error, then the build is running successfully. So all these are the things which Maven makes very easy. So other than this, Maven also helps us to generate sample projects. There is a great thing called Maven archetypes which helps us to generate projects. I mean, you can even say mvn eclipse and create workspaces, Eclipse workspaces, IntelliJ workspaces, and what all. So you can see that defining Maven is so difficult because it helps us to do so many things. Yeah, so let's look at one of the simple things that Maven helps us to do. One of the things that Maven helps us to do is to create the jar for a project, right? So when I have an app.java and I would want to run, I have a test file called apptest.java. One of the things I would want to do is to compile this class, run the test, and check whether the test is running fine. If the tests are running fine, I would want to build the jar and give it to my friend who wants to use that jar. So if you wanted to do something of this kind earlier with Ant, it was very, very tedious, right? You have to do a lot of steps to be able to create this. So Maven came up with something called convention over configuration. So it defined a it came up with a predefined folder structure. Maven came up with this folder structure: source main Java, source main resources, source test Java, source test resources. So all your Java code is in here. All your resources that you need, like XML files or anything else, is here. Property files. All your test code is here, and this is where your resources are there. So once you adhere to this folder structure and create a simple pom.xml defining your dependencies, then you don't need to do anything. All that you need to do is run mvn compile, then you can compile your code. Mvn test compile, this compiles your test code and also source files. Mvn clean, this deletes your target directory. Mvn test, this runs your unit test. So Maven came up with a structure, and once you adhere to that, so once you adhere to that convention, then it's easy to do different things around the whole thing. So that's what is called convention over configuration. Again, the important thing is this structure is not mandatory. You can override it by simple configuration in the pom.xml, but that's the default. The default is source main Java, source main resources, source test Java, source test resources. How does Maven do that? Maven does that by defining something called a Maven build lifecycle. So it's basically a predefined sequence of steps when we run a Maven command. So when I do a mvn install, what Maven does, it runs all these steps before it. So when I run mvn verify, it runs everything. If I run mdn deploy, then it runs everything which are selected right now. So this is called a build life cycle. So the build life cycle is basically the steps which Maven runs when I run a specific command. So when I do a mvn test, what does Maven do? First it validates, then compiles both test and source code, and then run the tests. If I do mvn package, all these 4 steps are run. If I do mvn install, all these 7 steps highlighted are run. This is what is called a build life cycle. What are the important parts of a pom.xml? Pom is nothing but a project object model. So the project object model is pom is nothing but a simple XML which contains name. So if another project wants to refer to other project to our project, how do they do that? So for example, Spring Framework. What's the name? It would be Spring-framework. Version. So version is basically which version of the framework. So if I'm developing Spring Framework, probably I would have multiple versions, right? I would start with probably 1.0, and currently it's 5 beta or something. So you'd have different versions. So you have the version of the current version of the project in here. And packaging is basically how you want to package it, whether you want to have it packaged as a jar, whether you want to create a var web archive, whether you want to package as a pom itself, which can act as a parent pom to other poms, or whether you want to package it as an EAR, enterprise archive. You can have multiple ways. Also present in the pom are the dependencies. What are the other projects you want to use? And also present in the pom are plugins. So if I want to be able to run an application in Tomcat, then I need the Tomcat plugin. If I want to run a check style, if I want to run check style on my source code, I need a check style plugin. If I want to put my code in Sonar, then I would need a Sonar plugin. So that's basically the project object model. So the next important concept in Maven is a repository. What is a repository? So basically Maven repository is where all versions of every jar is present. So over here I'm saying I want Spring Framework, Spring context jar of this version. So I'm using a variable here. The value of that is 4.1.6. So I'm saying I want Spring context version of 4.1.6. So how does Maven go and get it? The Maven goes to a repository. It's called a central Maven repository. You can configure the repositories in a file called setting.xml on your local Maven installation. However, by default, it goes to the Maven central repository and looks for this particular file. So it's almost like a query. So Maven goes to the central repository and asks, I want this artifact with this group ID, artifact ID, and version. The central repository will find the version and give it to Maven. What Maven does is it takes it and puts it to a local repository on the machine. The advantage of having a local repository is if I have multiple projects using the same version, I don't need to download it 100 times. It would be downloaded once, and from the next project on, it will be reused from my local repository. This will prevent me from needing it to download it multiple times again and again and again. So basically the way it works is there's a central Maven repository or a central set of Maven repositories. Certain corporate companies have repositories of their own where they maintain all the jars themselves so that it's more secure. So you kind of have that as the central repository. Your local repository is whatever is on local machine. So once you download the file from your central repository to your local repository, in your project you will refer the file from your local repository. This also helps in saving bandwidth, because if I'm using Spring in multiple projects, then I would rather use it. I mean, I would have one version in the local repository rather than keeping on downloading it again and again. The Maven central repository shows all versions of the dependencies. So everything so all the versions of JUnit are present on the Maven repository. And local repository, all the dependencies that are downloaded for the first time are shown. The first time I use JUnit 4.2, it would be downloaded and put into my local repository. Next time another project refers to 4.2, it does not need to download it. It will use it from the local repository. That's the advantage of having a local repository. One of the important concepts in Maven is a transitive dependency. So what is a transitive dependency? A transitive dependency is nothing but dependency of a dependency. So if you look at Spring Beans, for example, if I go to the POM files, if I click this, control click, it will take to the POM of that particular thing. You'd see that this Spring Bean has its own dependencies. So Spring Bean has its own dependencies. So some of them are optional, some of them are not really optional. So for example, the Spring Beans, one of the dependencies is Spring Core. So this is called a transitive dependency for my project. So if I'm using Spring Beans and I get Spring Core because I'm using Spring Beans, then this is called a transitive dependency. If we look at the Spring JDBC project, I'm using Spring JDBC, and if I open up the POM for Spring JDBC, it contains Spring Context, Spring Core, Spring TX. So these are all transitive dependencies for my Spring JDBC project. So whenever I use a dependency, I also get the transitive dependency. So whenever I use this dependency needs these things. So they will also be downloaded and placed in my local repository and made available for my project. That's the advantage. Once I put a dependency on Spring JDBC, I get all the things that it needs to be able to run. So I don't need to individually go and download all the things which it depends on. So that's the advantage of using a transitive dependency. So exclusions is when I would want to exclude a specific jar. So I'm getting a transitive dependency, but I don't really want to have one of those things to be present. Then I can say exclusions, and let's say I don't want to get, I'm just taking this at random. Let's say I don't want to have Spring Beans among my dependencies. So I'll go and put a exclusion on that particular dependency, and then oops, I should use exclusion, not dependency, my mistake. So I don't need to specify the version and the scope as well. So now Spring Beans will be excluded. So even though Spring JDBC says I want Spring Beans, because we specified an exclusion, you will not get Spring Beans. Dependency hierarchy is to see how we are getting all the dependencies. So if I go to the dependency hierarchy, it shows how I'm getting the different hierarchy of things. So Spring JDBC, it depends on Spring Beans, Spring Core. So if you see Spring Core, how am I getting it? I'm getting it through Spring JDBC. Why am I getting Spring JDBC? Because I directly included it. Spring TX, because Spring JDBC needs it. I can see why log4j, because I directly included it. Comments logging, I'm getting comments logging because it's JDBC. So I can see how I'm getting a specific jar by looking at the dependency hierarchy. The next important thing is scope. So for all the things in pom.xml, you can specify something called scope. All the dependencies, I mean. Scope can have a value compile, which means it's available for compile, runtime, and everything. So it's available when this jar would be available when I'm compiling the code, when I'm running the code, and it would be part of the jar or the var, whichever one you're using. You can also create a scope called provided. It would be available at compile time, but it would not be part of the jar. I mean, it will not be part of the var because this would be excluded. This would be used in the circumstances where this jar is provided by the application server or the web server. So if Tomcat is going to provide this var when I'm running this, I would only need it for local compilation. Once I'm able to compile it, when I'm running it as part of the var, then I would not need it because the var would be provided by the Tomcat server. The other one which is there is runtime. This is basically when you don't need the jar at compile time. So this jar will not be available at compile time. So when I'm compiling the code, this will not be available. So I'll not be able to use any classes from this at compile time, but this class will be available at runtime. So those are the different scopes that are important. The other scope is test. Basically, this is only available when you're running, when you're compiling and running your test classes. So the important scopes are test, basically to be able to run it in a test. So use test scope. The other ones are compile and runtime. Compile is almost everything. So your source files, your test files, when you are running it, everywhere it would be there. Runtime is when it's only available at runtime. It will not be available for compile. And provided is when your jar is going to be provided by your application or the web servers, then it would be only available during compile and it will not be packaged as part of your var. The next thing is effective POM. Effective POM is very useful. So earlier when I showed the dependency hierarchy, this is where we were. When I open it in Eclipse, it shows this way. Probably the screen got cut up at the bottom portion of the screen got cut out of the screen. So whenever we showed the dependency hierarchy, this is where we were. And now we want to see the effective POM. Effective POM is like the complete hierarchy of the POM. So the POM here, if you look at it, it only contains 35 lines. But actually, every POM in Maven inherits from something called a parent POM. So the parent POM of Maven contains a lot of defaults. So all the things that we think are uh, by default convention over configuration are actually defined in the Maven parent POM. So if you look at it, this is the resources folder. Where is it defined? It's defined in the parent POM. So you see output directory, source directory, everything is defined as part of your parent POM. So uh, going to the effective POM would help you to see everything related to that. So effective POM is kind of like the complete POM that is used to run your entire thing. Even though you are having only 35 lines, because of the convention of configuration, convention over configuration, and the existence of a Maven parent POM, we get all the defaults from the parent POM. The effective POM shows all that stuff. Some of the important comments which you can see is help effective settings. It will show all the settings which are being used. You can see what are the repositories and all that kind of stuff. Help effective POM would show you the effective POM that we looked at earlier. Dependency tree shows the dependency tree that we looked at earlier. Dependency sources would actually get all the sources for that specific code and make them available for you. So all the dependencies, like if I'm using a Spring framework, it will get the sources and make them available for us. Archetypes is one of the important things related to Maven. Archetype generate is one of the commands which you can try, MVN archetype generate. You can generate a lot of sample projects. If you want to generate a sample MVC projects, sample Spring MVC or struts or JPA project, you can use archetypes to generate that up. So the idea behind this was just to give you an overview of all this stuff around Maven. There are a lot of things that related to Maven which is not really possible to cover in a 20-minute video. So we really recommend you to go through the Maven course which is present in here and spend some time with it and understand Maven in complete. There are other courses, Java EE patterns, which help you to understand the evolution of Java EE, and also we have courses on Spring MVC and JSP servlets which might be interesting for you. This video is part of a series of 25 videos which we have created, and all the links to those videos are present in the GitHub repository, github.com/in28minutes/interview-guide. So you can find the link in the description of the video as well, and you can watch all the other videos as well. One of the facts that we really believe at in 28 minutes is all these interview guides are useful once you are an expert at something, or once you have a little bit of experience with that. So there are a lot of courses that we have: Java EE patterns, Spring MVC, JSP servlets, Maven. These are all really good courses. We also have a complete 5-hour course on Java interview questions and answers. It's almost 6 hours of videos on different things related to Java. So Those are the things I think you will find interesting after watching this video, and if you liked it, I'm sure you'll like the other courses as well. So give them a try, see if you like them. uh, you can make the best use of this Git repository which is present in here. Good luck with all your interview preparation. Until next time, this is bye from Ranga at in 28 minutes.